How did Native Americans build sturdy dwellings without nails? Their secrets will shock you. Before us is a house as tall as a two-story building, capable of accommodating 100 people, or an elegant conical dwelling that can withstand the hurricane-force winds of the Great Plains. Now imagine that all of this was built without a single metal nail, screw, or staple. Native American engineers did not have metallurgy, but they had knowledge that allowed them to create incredibly strong and durable structures. Their secret lay not in strength, but in a deep understanding of the nature of materials and the laws of physics. They did not conquer nature, but cooperated with it, turning flexible saplings, strong tendons, and tree bark into perfect building elements. It was architecture based on flexibility rather than rigidity, on connection rather than penetration. Watch the video to the end to learn how ancient engineers created living houses that breathed with nature, and what one secret material made them stronger than stone. What if I told you that everything you knew about construction was just one of many possible approaches? For indigenous builders, wood was not just a dead material to be cut and hammered together. It was a living organism with its own character, strengths, and weaknesses. Before cutting down a tree, the master studied it for a long time, determining how it grew, how it bent in the wind and sun. He looked not just for straight trunks, but for those that already had natural bends suitable for the future structure. It was a dialogue with the forest, not just the harvesting of wood. This approach allowed them to use the natural strength of the wood rather than fight against it. Instead of breaking the fibers, builders followed them, bending and joining elements as nature itself suggested. The result was not rigid skeletons, but flexible and elastic frames. They knew that young willow or hickory had incredible flexibility, ideal for creating arches. At the same time, mature cedar or oak provided strong, straight posts capable of supporting enormous weight. Each tree had its own purpose in the overall structure. It was not a craft, but an art of persuading the wood to take the desired shape. The craftsmen used steam, water, or simply slow bending over a long period of time. They did not force the material, but guided its internal energy. Their tools were not saws and hammers, but sharp stones, bone scrapers, and most importantly, boundless patience. The construction process was slow and meditative, requiring complete immersion. The result was houses that stood for decades, harmoniously blending into the landscape. This attitude extended to all materials, whether stone, clay, or animal skins. Each element was perceived as a gift from nature that must be used with respect and wisdom. This was the main secret of the durability of their buildings. We would be very interested to hear your opinion. Do you think modern architects should learn from this approach to materials? Write about it in the comments. Want to know the secret that held entire civilizations together without a single nail? The main answer to the lack of metal was the art of binding, perfected to perfection. Instead of nails, Native Americans used two basic materials: animal tendons and plant fibers. Tendons taken from bison or deer were a natural substitute for super strong glue and nylon ties. They were carefully cleaned, separated into thin fibers, and dried. Before use, they were soaked in water to make them elastic and pliable. The wet tendons were tightly wrapped around the joints of the wooden frame elements. The secret was that as the tendon dried, it contracted with tremendous force. It pulled the parts together so tightly that the joint became virtually monolithic. Such a joint was not only strong, but also elastic. It could play a little under the load of wind or snow without breaking. This gave the entire structure a dynamic stability that rigid nail joints lack. The second key material was bast, the inner layer of the bark of certain trees such as linden or elm. In the spring during sap flow, the bark was easy to remove in whole strips. It was then soaked in water for a long time until the strong fibers separated. These fibers were woven into ropes and cords of various thicknesses. They were incredibly strong and resistant to rot. Such ropes were used to tie together the massive beams of longhouses or to secure the covering of wigwams. The process of harvesting and processing these materials was long and laborious. It required a deep knowledge of botany and anatomy. This knowledge was passed down from generation to generation as a great treasure. Every knot and every wrap was the result of centuries of experience. There were dozens of different binding techniques for different types of joints. It was a whole science, no less complex than modern engineering. Thus, the frame of the house was literally sewn together, not nailed together. The fibers penetrated the structure of the wood, creating a single whole. It was an organic connection, not a mechanical one. Which of these materials do you think was more versatile in construction? Animal tendon or plant fiber? But binding was only half the battle. Ready to learn how Native Americans made trees grow in the shape they needed, creating frames that didn't even need to be cut down? A secret passed down from generation to generation: how to build a house without killing a single tree. One of the most unique and environmentally friendly construction methods was the creation of living frames. This technique was used by many forest peoples to build domed dwellings such as wigwams. Builders would select a group of young, flexible trees, such as willows or hazel, growing in a circle. They would not cut them down, but carefully bend their tops toward the center. The tops were tied together to form a sturdy dome-shaped vault. Over time, these bent trees continued to grow, but in the shape that had been given to them. Where they touched, their trunks could grow together, forming a single monolithic frame. Such a house became part of the forest, rather than a separate object. The strength of such a structure was phenomenal. The living walls, rooted in the ground, could not be blown down by the wind. They possessed natural elasticity and flexibility, withstanding any load. The space between the living supports was filled with additional, already cut poles and branches. The frame was covered with bark, reed mats, or skins. The result was a warm and reliable house, literally grown from the ground. This method required incredible patience and the ability to plan years ahead. The builder had to anticipate how the trees would grow and develop. It was a joint effort between man and nature. Such houses were not just dwellings, but living organisms. They changed with the seasons, providing shade in summer and retaining heat in winter. Their walls literally breathed. Of course, this method was not suitable for all types of dwellings, but the very fact of its existence overturns our understanding of the possibilities of pre-industrial construction. It proves that the most durable solutions are often the most organic. Guess how long it took the Lakota family to assemble and disassemble their home? The life of the peoples of the Great Plains was inextricably linked to the migrations of bison, so they needed a mobile, but at the same time very durable home. Such a home was the Tipi, an ingenious conical engineering structure. The Tipi is based on a frame made of long, straight, and light poles. Pine trees growing in the foothills of the Rocky Mountains were the ideal material for these poles. Entire expeditions were sent out to find such poles, as there were no suitable trees on the plains. Assembly began with the installation of a tripod or 4 main support poles. They were tied together at the top, and the lower ends were placed on the ground to form a base. This primary frame was the key to the entire structure, providing it with initial stability. Then the remaining poles were placed on this base, evenly distributed in a circle. There were between 15 and 25 of them, depending on the size of the tipi. The lower ends formed a perfect circle, and the upper ends converged at a single point, creating a sturdy conical structure. The conical shape was not accidental. It has incredible aerodynamic stability. The strongest winds of the plains simply flowed around the tipi, without creating critical pressure on any side. A covering sewn from 10-20 bison hides was stretched over the frame. It was heavy and durable, further pressing the poles to the ground and increasing stability. At the bottom, the covering was attached to the ground with wooden pegs. There was a smoke hole at the top of the tipi. On either side of it were 2 special flaps, or ears. These flaps could be turned with separate poles depending on the direction of the wind. What do you think was more difficult, finding perfectly straight poles or sewing a huge covering from animal skins? But the cone was ideal for the plains. In the next chapter, you will learn how the peoples of the forests built giant fortress houses that could accommodate entire villages. The peoples of the Northeast, such as the Iroquois, led a sedentary lifestyle and built completely different dwellings. Their longhouses were monumental structures, reaching up to 100 meters in length. An entire clan community of several dozen people could live in one such house. The frame of a longhouse was a complex system of posts and beams. 2 rows of sturdy vertical posts made of strong wood, such as elm or oak, were dug into the ground. These posts formed the long walls of the future house. Horizontal beams were laid on top of the posts, which served as the basis for the roof. All connections were made without nails. Grooves and spikes were cut into the posts and beams, which fit tightly into each other. Long, flexible saplings were used to create a vaulted roof. They were dug into the ground along the main walls and then bent toward each other, tying the tops together. The result was a sturdy arched frame capable of withstanding the weight of snow. Cross beams connecting opposite walls gave the structure additional strength. Inside the house, 2 tiers of sleeping platforms were built on these beams. The space under the lower platforms was used to store supplies. The walls and roof were covered with large sheets of elm bark. The bark was harvested in the spring when it was easy to separate from the trunk. The sheets of bark were laid overlapping, like tiles, and pressed against the frame with external poles. This covering was waterproof and retained heat well. The gaps between the sheets of bark were filled with moss and clay. In summer, part of the bark could be removed to improve ventilation. Such a house was not just a dwelling, but the center of social and ritual life. Its monumental size and sturdy construction symbolized the unity and strength of the clan. It was the material embodiment of their social structure. What if I showed you a time machine that would take us to an ancient carpenter's workshop? To create sturdy frames, especially in monumental structures such as longhouses, ropes alone were not enough. Master carpenters used complex joinery joints carved with stone and bone tools. One of the most common techniques was the mortise and tenon joint. A protrusion, or tenon, was carved at the end of one beam. A hole of the corresponding shape and size, or mortise, was hollowed out in the other beam. The tenon was driven tightly into the mortise, creating a strong connection. To secure it, a wooden wedge or pin called a dowel was driven into the hole drilled through it. It was, in essence, a wooden nail that worked on shear. This technology required incredible precision. The tenon and mortise had to fit together perfectly, without any gaps. Craftsmen spent hours cutting and adjusting the parts to achieve a perfect fit. To connect logs at an angle, for example, at the corners of a log house, various types of locks or notches were used. The simplest was the bowl, a semicircular recess into which another log was placed. More complex locks, such as the dovetail, provided even stronger adhesion. Gravity was actively used in the creation of frames. The structure was designed so that the weight of the upper elements pressed down and fixed the lower ones. The whole house worked as a single system, where each element supported another. The tools for such work were simple but effective. Stone axes and adzes were used for rough woodworking. Sharp chisels made of flint or beaver teeth were used to cut precise grooves and tenons. Which of these techniques seems most reliable to you? A carved lock, a wooden nail, or a rope tie? We figured out the frames, but how were they protected from rain, snow, and wind? In the next chapter, we'll talk about the ingenious materials for roofs and walls that nature itself provided. The frame is just the skeleton of the house, which needs skin to protect it from the outside world. The choice of covering material depended on the climate, available resources, and lifestyle. The 3 main materials, bark, skins, and earth, demonstrate the remarkable adaptability of indigenous peoples. In forested areas, tree bark, especially elm and birch, was the best roofing and walling material. Elm bark was thick, strong, and flexible. It was stripped in huge sheets in the spring, then flattened under a press and used to cover longhouses. The sheets of bark were laid like giant tiles, ensuring complete waterproofing. Over time, under the influence of the sun and rain, the bark became hard and durable. Such a covering lasted for many years before it needed to be replaced. On the Great Plains, where there were no large trees, bison hides became the ideal material. It took 10 to 20 carefully processed hides to cover one tipi. Women sewed them together with tendons, creating a huge single canvas. A properly tanned bison hide was durable, flexible, and waterproof. In the heat, it breathed, and in the cold, it contracted, keeping out the wind. In addition, the semi-transparent hide allowed light to pass through, making the interior of the dwelling bright. The third unique type of covering was used by river valley peoples, such as the Mandan and Pawnee. They built large dome-shaped earth houses. Their massive wooden frame was covered with a layer of willow twigs and grass. A thick layer of turf and earth was laid on top of this base, Such a covering reached a thickness of several tens of centimeters. It provided phenomenal thermal insulation. In winter, these houses were warm, even in the most severe frosts. In summer, the thick layer of earth protected them from the scorching sun, keeping them cool inside. They were true natural bunkers, ideally suited to the continental climate. The choice of covering was not accidental, but the result of centuries of observation and experimentation. It reflected a deep understanding of the properties of each material. It was a science of building materials born from practice. Native American dwellings were not just passive shelters, but active systems that interacted with the environment. Their design included thoughtful elements for ventilation and thermoregulation. It was an early form of a smart home operating on the laws of physics. The most striking example is the Tipis smoke vents. 2 ears at the top of the cone allowed for precise draft control. By turning them into the wind, it was possible to create an area of low pressure that effectively drew smoke out of the hearth. In addition, Tipis often used an inner canopy or lining. This was a second wall made of skins that ran along the inner perimeter and did not reach the ground. It created an air gap between itself and the outer covering. This layer worked on the principle of convection. Cold air entered from below, under the edge of the outer covering, was heated by the hearth and people, rose up in this layer, and exited through the smoke hole. This created constant air circulation, preventing drafts and retaining heat. In the longhouses of the Iroquois, ventilation was even easier to regulate. The bark covering was not airtight. By sliding or lifting individual sheets, it was possible to create ventilation in the desired areas. In winter, all the gaps were carefully sealed with moss, turning the house into a warm and windproof fortress. In summer, on the contrary, some of the wall panels could be completely removed. This turned the house into a shady, well-ventilated canopy. In earthen houses, the entrance was usually a long corridor, partially sunk into the ground. This corridor acted as a temperature lock. It prevented cold winter air from entering the living quarters directly. As a result, a healthy and comfortable microclimate was maintained inside these houses. They were warm in winter, cool in summer, and always well ventilated. This was the key to survival in harsh climatic conditions. Behind the strength and functionality of all these structures was an invisible engineer: geometry. Indigenous builders intuitively understood and utilized the strength of certain shapes. These shapes were not the result of complex calculations, but of centuries of evolution and observation of nature. The cone is one of the most stable and durable structures in nature. Its shape distributes wind load evenly across its entire surface. It has no flat walls that would take a direct hit from the wind. In addition, the round base of the cone has a minimum wall area with maximum internal volume. This means less heat loss in winter. The hearth, located in the center, evenly heated the entire space. The dome of a wigwam or earthen house is another shape borrowed from nature. The arch structure works mainly on compression, effectively distributing the load from snow or earth cover. There are no weak points in such a structure that could break. The hemispherical shape also has excellent aerodynamic properties. It easily withstands wind from any direction. As with the cone, the round base minimizes heat loss. The rectangular shape of a long house seems less natural, but it also has its own logic. It allowed for the most efficient use of interior space to accommodate a large number of people. It was social geometry, subordinated to the needs of the community. However, here too, builders used reinforcing elements. A vaulted roof rather than a flat or gabled one gave the structure additional strength. It easily shed snow and rainwater. Even the layout of dwellings in a settlement was subject to the laws of geometry and strategy. Houses were often arranged in a circle, creating a protected central space. This layout facilitated defense and created a sense of community. The strength of their architecture lay in the simplicity and efficiency of the chosen forms. They did not invent anything superfluous. Every line, every curve was dictated by necessity and the laws of physics. None of these grandiose structures could have been created alone. Building a house was not just a technical task, but an important social event. It united the entire community, strengthening social ties. The construction of a longhouse by the Iroquois required the coordinated efforts of dozens of people over several weeks. The men worked together to fell trees, carry heavy logs, and erect the frame. This joint effort required clear organization and mutual assistance. Women played an equally important role. They harvested bark, wove mats and ropes, and prepared food for the builders. The entire community worked as a single organism, pursuing a common goal. Even the construction of a tipi, although it was the work of one family, often required the help of neighbors. Women gathered together to sew new coverings, sharing news and experiences. This process was an important part of social life. Construction was not just work, but a ritual. It was accompanied by songs, ceremonies, and a communal celebration upon completion. A new house was a joy for everyone, not just its future inhabitants. This collective approach ensured not only speed, but also quality of construction. People worked conscientiously because they were building for their families and loved ones. Mistakes or negligence were practically impossible. In the process of working together, the elders passed on their knowledge and skills to the young people. The construction site became a school where young men learned carpentry and young women learned how to process skins and bark. This ensured the continuity of traditions. A house built collectively was perceived not as private property, but as part of the common heritage. It was a symbol of unity and mutual assistance. Its strength reflected the strength of social ties in the community. Thus, engineering technologies were inseparable from social organization. Strong houses could only be built in a cohesive society. The physical structure of the dwelling and the structure of society supported each other. Ultimately, the main binding material was not tendons or ropes, but human relationships. It was the spirit of cooperation and community that made it possible to create these amazing structures. Without it, even the most ingenious engineering ideas would have remained only on paper. We can see that the absence of nails was not an obstacle, but rather a stimulus for the development of ingenious engineering solutions. From living frameworks that grew together with the forest to mobile tipis that withstood storms, Native American architecture was the pinnacle of adaptation and understanding of nature. Their homes were not just buildings, but complex living systems created in harmony with the surrounding world. The secret to their durability lay in three pillars: a deep knowledge of materials, an ingenious use of geometry, and the power of community unity. This legacy teaches us that the most sustainable solutions are often not the most technological, but the wisest and most holistic. What other aspects of Native American life would you like to see in future videos? Suggest topics in the comments and don't forget to subscribe so you don't miss new episodes.